You know what I want to do today?
What?
I want to learn about two-dimensional projectile motion.
Let's do it!
So what's projectile motion?
I'm glad you asked. Projectile motion is when the object in motion experiences a change in position on the x and y planes.
So what's an example?
Here's an example.
Wow, that was a cool example. I have a question.
How does the initial velocity affect the peak height of the ball?
Let's take a look. Here are 3 different examples.
What procedure did you use?
For our procedure, we changed the initial velocity at which the ball was released, but each time we kept the position at which the ball was released the same. Then we monitored how the changing initial velocity affected the vertical height or the peak height of the ball. As we could see from these results, when the ball was released at a greater initial velocity, the ball reached a greater peak height.
How does initial diagonal velocity affect the amount of time that the ball is in the air? Okay, so if we want to find the time that the ball is in the air, we're going to use this kinematic equation. So in order to find v final and v initial, we need to find the diagonal velocity. And in order to find the diagonal velocity, we have to do this equation here. We can think of this basically just as the Pythagorean theorem, where this is Vx, this is Vy, and then this right here, this is the velocity. The Vx initial is 1.623 meters per second, and the Vy initial is 2.7. And so then we just plug these into this equation here, and we get 3.799 meters per second. Then we have to do the same thing for V final in order to find V final. And so the Vx is 1.361, and the Vy final is negative 4.616 meters per second. Again, plug this into our equation to find diagonal velocity, and we get 4.8125 meters per second. And we know that our acceleration is going to be 9.8 meters per second squared. So then we plug these into our kinematic equation, and we get for trial 1 that the time that the ball is in the air is 1.602 seconds.
We use the kinematic equation v final equals v initial plus acceleration times time, and we solve for t, which showed us initial diagonal velocity increases, so does the amount of time the object spends in the air.
Wow, I learned a lot.